In this video, we're going to look at example 1 where we find all real nth roots. So the question in part A is what are all the real cube roots of 125? And this is just kind of some definition terms here. An nth root of a number c is x, such that x raised to the n power is equal to c. So an nth root can be denoted by a radical symbol with an index of n, which looks like that, and c is called the radicand. So really what we're looking here is what are all the real cube roots of 125? So what that can be rewritten as is we're looking for x is equal to the cube root of 125. Right? Pretty straightforward. And what we can do is we can rewrite that looking at this here, x to the n is equal to c, c being that radicand, that's on the inside. So I'm going to rewrite this as x to the third power, or what number to the third power gives me 125. Right, so if we were to try and solve this, if we really could think about this, what's going to happen is that x would be equal to 5, because 5 times 5 times 5 gives us 125. We'll keep that pretty straightforward, and we would just say that what are all the real cube roots? Well, this is going to be the answer. Kind of looking a little bit more into that, what we have here is if we take this x cubed equals 125, and let's just say we were set this to equal to 0 by subtracting 125. This is not something in this specific problem you would have to do, but I want you to see what's going on here. Now this x cubed minus 125 is a difference of two cubes. So if we were to factor this, again taking some shortcuts here, this would be x minus 5 times x squared plus 5x plus 25 is equal to 0. Sorry about that, is equal to 0. And if we set each of these pieces equal to 0, here we get that x equals 5, which is what we already had. But if I was to take this second term, or second expression, sorry, and set that equal to 0, I would solve this using the quadratic formula, because it's not a factorable problem. But what I would find is that inside the discriminant, b squared minus 4ac, I would have 5 squared minus 4 times 1 times 25, and I would get 25 minus 100, which is going to give me a negative number, in this case negative 75. So that's going to be an imaginary number, right? It's not a real root because we have this negative here that would have to come out as an I value. So this expression, this piece here, doesn't give me any real roots. So the only real cube root of 125 would be this x equals 5 piece. All right, and that would be it. Looking at part B, what are all the real fourth roots of 16? Well, we're looking for the same thing. So what number is the fourth root of 16? And what I can do is I can rewrite that as x to the fourth power is equal to 16. All right, and maybe you can figure this out in your head. You can try like 2 times 2 times 2 times 2 or 3 times 3. But let's do the actual kind of mathematical process behind it. So I'm going to set this equal to 0. Right? I'm going to subtract that 16 from each side. And this is the difference of two squares. So this can be factored as x squared plus 4 times x squared minus 4. And I can then factor that again. All right, that one I can't do anything with that. But this piece is another difference of two squares. So this is x plus 2 times x minus 2, and that would be equal to 0. That tells me I can take each one of these pieces and set them equal to 0. Let's set that equal to 0. Let's just move this over a little bit. So here, I'm going to subtract 2, do the easy ones first. So I have negative 2 is a real fourth root. And here I'm going to add 2, so this would be a positive 2. So positive 2 is a real fourth root. Over here, however, if I was to try and take the square root, again, I'm going to have an I value in there. And I'm not even going to finish that one. All right, but since that's an I value, that's going to be an imaginary root, so we don't care about that. All right, we're just going to eliminate it. So the real fourth root, or sorry, roots of 16 are 2 and -2. And you can kind of write that in whatever way you want, but that's the idea. Go back to this definition, just kind of understand what the cube roots are, what the fourth roots are, and how they can be written as both with a variable and using kind of this your square root symbol that everyone should be familiar with at this point. All right, and that's it for B. The try it problems will give you a little bit of practice on that. You have a fourth root and a cube root problem, so you can kind of work those out the same way.